Alright, so 3.3 is video 2, and we're going to start out with example 2, which just wants us to write the expressions in expanded form. So we're just going to expand these. And so you can see we start out with one logarithm, and so they're just more difficult than what we did in example 1. But notice you have some things going on. You've got the top here where they're being multiplied. You've got the bottom, but first thing before you can actually touch the top or the bottom, you've got to separate them. And so we can separate them because they're being divided by subtraction. So we can rewrite this as log base 2 of the x squared times x minus 1 cubed minus, because it was division, log base 2 of 2x plus 1 to the 4th. And so all I did was I did log base 2 of the top minus log base 2 of the bottom. Then we can start working from there. So we see on this first part, we have two things here that are being multiplied. So I'm going to separate them. So remember, you can separate them by addition. So I've got log base 2 of x squared plus log base 2 of the x minus 1 cubed. And then I've got my minus sign. And right here, though, the only thing I can do right now is I can move that 4 in front of its log. So it's minus 4 log base 2 of the 2x plus 1. Now, can we do anything else? Yes, we can. Notice when we look at this first log right here, we have an exponent. So let's move it in front of its log. So we got 2 log base 2 of x plus, same thing on the second log, we've got that exponent of a 3, so we can move it in front of its log. So 3 log base 2 of x minus 1. Now keep the x minus 1 in parentheses because it goes together. We got to show that it stays together. And then we got our minus 4, and we can't do anything else with this other log. It's just log base 2 of two things already being added together. So we're just going to bring it down. So minus 4 log base 2 of 2x plus 1. And so let's check. We don't have any exponents. We don't have anything being multiplied. We don't have anything being divided. And we don't have the log of a number by itself. So this is as far as we can expand this. So there's our answer for A. I'm not sure I have enough room on there for B, so I'm going to go ahead and start erasing A. So if you're not finished, make sure you pause the video, or you can back it up, whichever you need. Alright, so moving on to B. Oops, let me turn on my pen. Alright, so B is log base C of x cubed y squared, the square root of x cubed y squared z to the 5th. Well, the first thing is we can't do anything with this, with the square root. And so remember we had talked about that. We could change the square roots the same as written to the 1/2. So we have log base C of what's underneath that square root. So x cubed y squared z to the 5th raised to the 1/2. And we can't separate those three things being multiplied inside the parentheses until we get rid of that exponent. So we're going to move that exponent over in front of its log. So when I do that, I've got 1/2 times log base C of the x cubed y squared z to the 5th. And now we can separate those three things being multiplied, because we know that when we multiply, we can separate by using addition. But this 1/2 now goes to with everything behind it. So I'm going to use a parenthesis here. So I'm going to have log base C of the first. It's being multiplied, so plus log base C of what was second. And it's being multiplied, so plus log base C of the third. And then we have exponents, so we can go ahead and move those exponents in front of its log. So I'm going to keep still my 1/2 here. And then it's going to be times, I have 3 log base C of x plus, we're going to move that 2 from an exponent to the constant in front. So 2 log base c of y plus, and we're going to move that 5 from the exponent to a constant in front of its log. So 5 log base c of z. And let's see, inside, I can't do anything else. So the only thing I have left is that 1/2 on the outside. And so we're going to take this 1/2 now, we're going to distribute it to all 3 terms here. So I have 1/2 times 3 log base c of x. So that's going to give me 3/2 log base c of x plus, and then I have 1/2 times 2 log base c of y. So that's just going to give me log base c of y, because 2 times 1/2 cancels, or it's 1, plus, then I have 1/2 times, I have 1/2 times 5 log base c of z, so it gives me 5/2 log base c of z. And I can't do anything else to expand it, so there is my answer for B. Alright, so that's the end of example 2, and that's going to be where I'm going to go ahead and end the second video. And we'll start example 3 here in just a minute.